Okay, so now we're on. And now I need to annotate. Okay, so this just says factors. So here's something we need to discuss. Later in chapter 6, you're actually going to solve things, like it'll say solve. And when you're doing application problems, which is word problems, you have to solve, meaning I want to know, oh, how fast is that train going, or how far are they going, or whatever, depending on what kind of problem it is. So in this case, it just says factor. And do you see how you do not see an equation? So what I want you to remember is that when you have no equation, you can't solve, okay? Do not try to solve because you can't. We're never going to know what x is. There is no equation. We're not going to solve for x. But what we have to do right now is factor. And I don't even like all of this stuff. I just want to see factor the trinomial completely. They're even giving you hints, you know, and I don't even like that. So if I say factor, you say greatest common factor. Is there one? That's step one, always most important. And then you say, yes, I see something in common between this one, and this one. These are three terms, they have something in common, and they all have a 3x in them. So Markeisha, this might be a little boring for you, but it never hurts to review. So this was a question a different person asked me. So 3x times what is 3x cubed, open, x squared. 3x times what is negative 15x squared, negative 5x, you see? Because this one times this one has to be that one. And then 3x times what is 18x. And then Tristan, this is 6-1, this first step here that I did. And then step 2, 6-2 is where you're going to continue factoring this trinomial if it's factorable. It's not always. So we're going to pull the GCF, we did that, done. Then we say, what is it? So I'm going to say identify. So this is in that factoring summary video. But you identify, what is it? Is it a binomial, trinomial, four-term polynomial? If it's 4 terms, you group, you double bubble. In this case, I'm going to call it simple. This is not something that people like to use as a word, but simple trinomial, because I want you to remember to keep it simple, open, close, x, x. And then you say, okay, this thing can be factored, maybe. And you say, well, what would my product be? Product is always that last piece. So you're going to say product is 6. And what is your sum? That middle piece, so negative 5. And then you find 2 numbers here that give you a 6 when you multiply them, and when you add them, they give you a negative 5. So be careful here. Sometimes it's a 6 and a 1, sometimes it's a 2 and a 3. If I try to use a 6 and a 1, one would have to be negative to make this happen. Well, then this would have to be negative, so that's not going to work. So it has to be the negative 2 and the negative 3. I borrow 2, I borrow 3, I owe 5. Negative 2 times negative 3 is positive 6, true. And since it's a simple trinomial, you simply put that in there. So you have your x. Don't forget this guy. This is the original GCF. And then you put those values in. And order doesn't matter because multiplication, and this is your final answer. Now it's completely factored. Does this help at all, or boring? It never hurts to read, make it solid. Go ahead.
So for this one in particular, I may have missed it somehow, but you couldn't do -6 and +1?
The reason, that's a great question. Okay, so let's try it. I need a product of positives and a sum of -5. So if you used a -6 and a +1, do you see how this would have to be a negative?
Oh, okay. Yes.
So this is where that's that dangerous one, and it's the same thing with the 24, the 4 and the 6 and the 2 and the 12. It's one of those. So that's why I like to bring my signs over here into that shape, and that way I'll never accidentally mess up.
Okay, that makes sense.
The other thing that students do a lot, so I'm going to cross this off because it didn't work. But the other thing that students do a lot of students don't like to take steps. They need immediate gratification. It has to happen right now. And what they do is they want to go straight from beginning to end. And a lot of them will completely butcher this thing. Like they'll do a 3 something and then they'll do a 6 and a 5 in here, and it just doesn't work. So you have to be careful, please. Don't do those steps. That's what they're for. You know, if we follow steps, then the stuff will work out and we'll get our final answer we like. So that was that one. So I'm going to clear that if it's okay. Yell at me if I need to slow down. And again, I have just what I brought from what people asked. You guys haven't really asked me anything, so if I'm boring you or wasting your time, don't feel like you have to be here. I'm just trying to help. So then here, do you see how here it says solve? So we went straight from 6.2, that was actually the end of 6.2 on that one, to 6.6. What's in between? A bunch of stuff. You know, so all that different factoring stuff, the factoring summary video, I really would like for you guys to watch that if you need it, because I don't want to repeat that whole thing. And I did some of that last time. Oh yeah, I remember I said, hey, I'll start back up here. Didn't I say that? That was a long time ago. I'd have to pull that sheet up, but I can work on a little more factoring if you want, and then we go into solving. You know, where we actually solve, and then like I said, I don't have a word problem, but you see how this one says solve. How do I know it's solve even if it didn't say solve? It's because I have that right here, that equal sign. So maybe I should go back and look at something. Solve, this is the end of 6.6, and then we have this piece here, it says subtract. You see how that's chapter 5. This is really for if Tristan wanted me to work it. I had one student ask me about, she just got confused on signs, and I'm like, all you have to do is distribute the negative sign through before you combine. You know, but this is subtraction, this isn't factoring, this isn't multiplication, this is just subtracting terms. Here's an exam review for chapter 6 and 7. So this is very similar to your 112. And here, do you see how at the top I titled this was last year, with snipped images 2019 comparison to online exam. I had a student who said, no, the online exam didn't look at all like the on-ground exam. Or online exam didn't look anything like the review I made available. And then I'm like, well, this is the view or the visual. Let me show you something. You see, this is the visual, for example, of what the review looks like, because that is made out of a test generator. This is what my math lab looks like, but can you see how it's still the same thing? You're factoring out a GCF. So I hope, you know, like this one here, I told her that you're actually better off with this one, because all you had to do was recognize that they both have an x to the 7th and pull it forward and put the rest leftovers in here. Where this one that my on-ground students had, they had to do 3 terms, you know, and they didn't just pull m's, they also had to pull a number. So, do I need to do this? Or we did this last time. I think we did some of these last time, except I didn't have that comparison thing up. You know, here's a 4-term polynomial. What do? You group? We talked about this. We'd worked this one, I'm pretty sure. So there's just extra examples. So what do you want me to do? There was something we didn't do last time. We didn't do these ones. Let me look at one. Okay. So I'm going to work this one. Can you see this okay? So when it comes to factoring, before we solve for anything, you know, you need to know how to factor. This is weird because this is not using my pen. There.
Are you able to pull the screen down some? Because I don't see the actual problem.
Yes, but then I see I'm going to put it up.
Okay.
Because if I pull it down, it shows the answer and I don't like it. It's distracting.
Gotcha.
And I don't want you guys to be influenced, you know? So here's something. If you have, okay, so I say factor and you automatically say GCF, you know? Is there GCF? And sometimes if there is, it turns into something easy. Like the last one, I pulled the greatest common factor of 3x out, and then all of a sudden the rest of it was simple, which was great. But you look at this and say, oh man, that's some big numbers, but is there a GCF? 64 consists of 8 and 8. So if you know your basic numbers, you know that 8s are a bunch of 2s. 2 times 2 times 2 is 8. So this is actually 2 to the 6th power, a bunch of 2s. This is 49 is 7 times 7. So do you see how if there's something in common, it would have to definitely, this one or that one have to be something in common. So there is none, okay? Not in this case. So first you ask, is there GCF? No. Then you say, what is it? You know, this is the same thing as identify. And then last time we talked about, hey, if we have a trinomial whose leading coefficient is not 1, meaning it's not simple, you don't just do open, close, what do you do? And then we said over the top, you know? And I'm gonna say over the top. And in this case, you would almost want to. So let me play with this for a second. If I go over the top, look at this, don't write this down. Please don't write this down. But if I go over the top, I don't even have a calculator handy, but I know that 64 times 49 is hideous. So I'm just gonna say that, you know, the number is huge. I don't wanna deal with this because then this has to be 112. Can you imagine? There's gonna be so many things I have to mess with to come up with that as a product and that as a sum. So if the numbers are huge, you know, if, is it maybe special? This is how I teach this class, as far as you need to identify what you're dealing with and then things become easier. So you actually have to think a little. You don't just always, you know, within the steps you have to think, is it maybe special? And if it's special, then you use, let me erase this mess. So I don't like that it's over the top is huge, okay? So I don't like that at all. So I'm gonna say, okay, is it maybe special? And then I will use my formulas. So there's a couple of formulas you could memorize. People struggle with these formulas, but this is how it goes. And you're allowed formulas. Actually, I put these formulas on the test. It's just people don't understand how to do them. So it only helps you if you understand it. So the formula is this: if you have an a squared plus 2ab plus b squared, then that factors into a plus b quantity squared. If you have an a squared minus 2ab plus b squared, it factors into an a minus b quantity squared. So back in chapter 5, when people were multiplying this is in one, you know, intermediate algebra with review, you would have probably foiled this, and as you foil, you get that double middle term. So let me show this one time. You know, this is a minus b times a minus b. You don't need to write anything down except the formula if you want it. But if you foil this, look at this, if you foil it, a times a is a squared, minus ab, minus ba. Can we see that ab is ba? Negative times negative is positive, b times b is b squared. And do you see how these two combine? And that's borrow $1, borrow $1, and so that's a squared minus 2ab plus b squared. So in chapter 5, people resist this because you can go straight from here to here, and people say, I don't like to deal with formulas, and I'm like, that's okay. But if you are later have to factor it, it's a nice thing to get used to, because I'm telling you, you can do this thing over the top, but it's kind of a torture. So why don't you play with this a little and say, maybe it's special, and then your life will be easy. So let's look at this. If it's special, this piece here would be something squared, and this is the plus 1, this is the minus 1. Doesn't matter. My formulas are up there above. So this thing here, this, you see how it's, if it's something squared. What squared is 64y squared? So I'm going to say a would be what? A would be what? Because, I'll work it down here. this squared has to be 64y squared. Do you see? So everything inside gets that exponent. So what would have to be here number-wise to make that 64 and 8? And what would have to be variable? It has to be y. Do you see how this quantity squared is 64y squared? True. So you say, oh, is this something squared? Yes, that something is 8y. So you do want to write this part down. You're not creating another line of an expression. You are just identifying what squared would give you this. And then you say, what squared gives me 49? Is there something squared that gives me 49? Right? And you can use your calculator if you don't know your basics. And sometimes these numbers are bigger, so you will need a calculator and say square root. But do you agree that 7 squared is 49? And then this doesn't make that a perfect square trinomial. These things are called, these two things are called perfect squares trinomials. Now, I don't like it. You actually get a benefit when you're in an online class. Look, this tells you it's a perfect square trinomial, which I really, really dislike. My test gen online, on ground for the tests that I make for on ground and the reviews, usually I just say factor completely. So if I remember to delete out the instructions, I just want to factor them. I don't want to say they're a perfect square trinomial because that's leading the witness. So anyway, if it's a perfect square trinomial, do you see how this was something squared and this was something squared, and this in the middle is a times b doubled. So this is really what I ask now. This is some squared true. This is some squared true. And then I'm going to say, I'm asking, okay, so that's important that I'm asking, is this 2ab, meaning a times b doubled? Whoops, I can't even spell this morning. So a times b is 7 times 8y is 54. What? No, 56. You know, a times b is 56y. And then is this that doubled? Or you can just say 2ab. So you take a times b and double it. And if it is, then you simply, I'll do it in blue. See, it'll take forever to do this stuff. Then you simply say, oh, that trinomial factors into a, b, that sign, whatever that sign was, and square. And then you can check it by FOIL. So usually in class, I get a response like, oh, this is nice because I don't have to go through the over the top. You could do this one over the top. But you're gonna have a hard time finding what that is. It's gonna be a 56 and a 56. Here's what's gonna have. This is gonna be huge. I don't know what that is. And this is a 56 and a 56, and this is a 112. And this is whatever 56 times 56 is. Good luck figuring that out. So, you know, like I'm giving it away because I know the answer already. But you always should think, is this special? Maybe. If this is something squared, this is something squared, and then is this a times b and doubled? And then you say, oh, wonderful. It just simply factors into that. How's this work? Not at all. So it's really,
that actually worked a lot better.
okay. So let's do one more of these, and that way there's one more, and it's a little more obvious, that next one. Where's my mouse? I think I saw it up here somewhere. Oh no, that's not it. Oh, I went in the wrong direction. Sorry, I'm not trying to make you dizzy. No, I could swear I had another one. Where'd it go? Well, I guess it's probably this one. So this one also says perfect square. See, when I pay attention, I count this out. I just say factor completely. So you wouldn't know this necessarily. And then you say, okay, I say factor, you say greatest common factor. Is there one? So you say GCF, you still ask. And then you say, well, that's 5s and that's 2s and 3s. So no. Then you say, what is it? Oh, it's a trinomial. Is it simple? No, it doesn't start with just x squared. So you would go over the top. 25 times 36 is hideous. So maybe it's special. You see, that's the thought process. So if it's special, A would be what?
Five.
And an X, yes? And B would be?
6.
And then you ask, don't worry about signs. You just ask, is this 2AB? So do you take your 5x times the 6 and you get a 30x and then you double it and you get a 60x. And then you say, wonderful. So it's simply A, B, this sign, and squared. And then you can check by FOIL or you can check by formula, but really most of you like FOIL better. So you see how that can be really easy, or you can make it hard. But you see, the reason I didn't want to use this one originally is because if you did this one over the top, it still works. And it's a little more obvious. If you do this one over the top, you have, I think it's a 900 and a negative 60. And this is a little more obvious than that last one because 30 and 30, you see? That's pretty easy. You can split the middle into 30 and 30, and then you can factor by grouping. But why not make it quick and easy if it's a formula? How done? Helpful, not helpful? And there's more of these, or maybe exactly the same ones in the review. I can't always grab new examples, but I forget from semester to semester. Have I done this before? It looks so familiar.
Will I end up having to do some of these?
Yes.
Am I doing some of these in this section I'm in, or when do I look at these kind of
You
problems?
will do this in 6.3 and 6.4.
Okay.
Yep,
Perfect,
6.3 and 6.4, and it's kind of weird because some of them are special and some of them are just, they're all non-simple trinomials, meaning they don't just start with an x squared
Right.
at that point. And then you have your binomials. So this book is a little odd the way it sections it. So yes, you will be doing these in this chapter by the end of this week.
Okay.
So by the end of this week, chapter 6 is due. So that's why I need to do I'll dig up some word problems, but I'm hoping Markeisha sends me a few links. If not,
So
I'll
what's like a square number minus a non-square number factoring?
say
Would
that
you
again.
like a square number minus a non-square number factoring?
Oh, you're talking about difference of squares.
Yeah, like one square number minus a non-square number.
Okay, hang on. Let me make sure I'm understanding you correctly. Let's just double check. Is it something like this?
Yeah, and how do you tell if it's like prime or not?
Oh, okay. So let's look at this one, for example. And it's just doesn't have numbers here, so it's kind of lame. But I say factor, you say greatest common factor, is there one? Then you say no. Then you say, what is it? Oh, it's a binomial. Is it maybe a difference of squares? So a squared minus b squared, that's that difference of squares. So you ask yourself, difference is important, right? That's a difference. That's the key. So you're subtracting. So if you had something like this, x squared plus 9, for example, you would say that's prime. You cannot factor a sum of squares. Difference of squares is different because if you, a squared minus b squared, the formula is a plus b times a minus b. And if you check it by FOIL, this will check by FOIL. That one will never check if you try to use some combination of stuff and multiplying. It's not going to work. So here you would say, hey, a squared minus b squared, what would a be? A would be x squared. I think we did some of these last time. And what would b be? B would be 9. And then you say, okay, difference of squares. Open, close, a plus b, a minus b. And then you ask, am I done? You see? So this is a difference of squares, yes. You factored it into this formula. You do need to memorize that formula. That's the only formula you really have to memorize. And then you ask, done? No, because there's another difference of squares, you see? So my handwriting is hideous. Those are F's. So this is the sum of squares. I'll leave that thing alone. But this is a difference of something squared and something squared. And if you FOIL all this stuff, it will go back to the original. Anything else will not go back to the original. So I'm going to give you a second and then ask me more questions, or am I covering this well enough?
Yeah, I think that makes a little bit more sense.
Okay. So this is a different formula, you know, so when it's a binomial, it's maybe a difference of squares. If it's a trinomial, it may be a perfect square trinomial.
Well, you have to factor out the x squared minus 9 to x plus 3 and x minus 3.
Yeah.
Okay.
Because this is a difference of squares, so you use that formula again. And that's why this is a different a than this one. But I'm just using that as a pattern, you know, so I'm going to say, hey, this is a difference of squares, so it splits into this thing. This is a difference of squares, so it splits into this thing. Yeah?
Okay.
So you break it down further. Now, sometimes students struggle because they think they want to continue messing with stuff. So let me clear this screen if that's okay. Is that okay?
Yeah.
And then let me look at what if this thing said x squared minus 81. You know what I'm saying? So sometimes this happens. And then students are like, oh, okay, I want to do x and x. And then they want to continue factoring this. And I'm like, it is a difference, yes. Something squared, yes. But something squared, no. You see? So this one has to end here. This is the end of the story. You can't factor it further, but some people just keep factoring stuff that isn't factorable. So make sure you ask, you know, is this sum squared? Is this sum squared? Is this a difference? And if it's a sum, you don't fiddle with it. The end, prime.
Okay, so as long as there's a subtraction in it, you can factor it more.
Yes, if it's subtraction and they're squares, they're items that are squared. Something squared makes that item. Let me look, see if there's another good example. I don't always come up with good examples. Here's one. Okay, so let me try this one. I'm going to write it up at the top. 4x to the 4th minus 16x squared. So we did one of these last time, I believe, and I said what you don't want to do, I asked the group, and I think Carrie answered, and I'm glad someone participated, but students like to immediately say, oh, A is 2x squared and B is 4x. Do you see that? And I'm going to say, please don't. Please don't, okay? Do not try to identify A and B right now. Honestly, this is one of the biggest mistakes students make. Not right now. We will later. So what are you supposed to do first?
Factor it by like taking the square root, timesing it by its weight.
Or factor it by going back to the first time you heard of factoring.
Oh yeah,
And that
greatest
was
common
it.
factor.
Very good. That was the greatest common factor at the beginning of chapter 6. So this is one of those things where I keep harping on it, and in the classroom I'm hollering and I'm threatening with the ruler and stuff. But I mean, it's really, really critical. If you don't do this, you're going to mess this up. So you always want to pull the GCF if there is one. Now on the last one, there was nothing, but on this one there is. You see how they both have, what do they have?
4x squared, I think.
No, you know, it's true, right? They both have a 4. That's the biggest number they both have. And then the x squared is the biggest variable they all have. So then you open and say 4x squared times what is 4x to the 4th? X squared, right? Because this times this has to be that. That's a 4. My. And then 4 times what is negative 16x squared, or 4x squared times what? So it's a negative 4, you see? This times this has to be that. And
Yeah.
then you say, can I factor further? Well, your GCF is done. You can't factor this further, but this then, is this done? And you say,
No,
well,
we
it's,
divide that into two adding ones since that's the subtraction.
or you just say it's a difference, yes? Something
Yeah.
squared and something squared, right?
Yeah.
So then you say the formula is a squared minus b squared is a plus b times a minus b. That's the one everybody needs to memorize. So you're going to factor this binomial into a plus b and a minus b. And don't forget to bring down with you that greatest common factor from the beginning. If you multiply all of this, you go back to the original. So what's beauty about chapter 6 is everything can be checked. Everything by using chapter 5. And if you didn't do chapter 5, that's just all the multiplication. So if you have a gap somewhere, you can go pick that up in chapter 5. How's this so far?
Yeah, I think I understand it better.
Okay, good. So that's what I'm here for, hopefully, to clarify some. Let me look at what else there is, but we need to start solving. So this is 6. I don't know what number. Oh, okay, I didn't take. Here, I don't have it written down what section it in, but you see how this is 7111. This is something I will cover next week when we start chapter 7. I hope we don't start chapter 7 this week. I think you guys, the chapter 6 will be due. So we did this one. We did this one. So I think we're good. Oh, Markeisha?
I thought we were starting chapter 7 this week. It's module 7. Or no, yeah, module, let me see, what was it?
I don't have, I should have printed off a schedule to
I
have
have it right here. Module 8 that's due on Sunday is chapter 7.1 and 7.2.
Oh, wow, yeah, it's summertime. Brutal. So
Yes.
I need to get we got to get the application problems done. 7.1 is not bad at all. If you can factor, 7.1 is cake. The problem is people can't factor. You guys can. I'm saying there's lots of people that just completely ignoring my cry for help, pay attention, come to class, watch the videos, you know. Okay, let's do a couple of these solves. And then if we have time, Markeisha, if you can, or maybe, where can I find one? I can look in the, I'm going to find an application problem, at least work one of them today. So that'll help you, because I know you're ahead and you want to get busy, you know. So when this says solve, I don't want to use that. I kind of don't want to use that one. I want to use this one. Did we do any for resolving? No. Okay. if you're supposed to solve a quadratic, this is quadratic, why is this quadratic? Because if you FOIL this, it's going to turn into an x squared, okay? So step one is going to be create standard form. And I'm going to go fairly fast, but this is ax squared plus bx plus c equals 0, meaning you need everything on the left side and you have to have a 0 on the right, okay? Or you can have a 0 on the left, you know, I mean, that there's no difference, 0 equals. What I'm saying is all the numbers, all the variables on one side, 0 on the other. So you would FOIL. I think this might be one, Markeisha, that you might have asked, but I just grabbed stuff out of the.
Yes, this was one of them that it was similar.
Okay. And I'm showing extra every single step right now. You know, before I might have just gone ahead and moved that 3x over. So these two combine. Then you bring your 3x over because you have to equal to 0. So you get x squared plus 6x plus 8 equals 0 because subtract 3x. And then you, so this is step one, create standard form. Step two is factor. Because we need to create multiplication. That's what factoring is, right? And then I'll real quick explain the zero factor law, but I really don't want to reteach everything, or I can't teach all this stuff we're going to do in a week, in an hour session. But and I wonder if some people aren't showing up. I had internet issues at first. That was annoying. And then my son or my husband, I kept getting interrupted. I know it's annoying, you know, but we're all doing the best we can. I feel like I did something wrong. Why can't I do this all of a sudden? Hang on a minute. X squared plus 8 plus 1 minus 3. I'm having a moment. I feel really dumb right now. I can't do this. 2 times 4. I had one of them where in the middle of while I'm doing it for this student, I'm like, duh, you know, but I can laugh at myself. That's the other beauty. You got to be able to laugh at yourself. Is this true? X squared plus 4x plus 2x plus 8. So usually I have the students do that stuff so I don't get embarrassed because my basic math is failing me while I'm doing everything else. Is this true? So you've created multiplication, and why is that? Why did you do that? Because I think they call it zero factor law in this book, but you know this from pre-algebra. This is a pre-algebra concept that if A times B equals 0, this is an if, okay? Then A is 0 or B is 0. Because I'm telling you, if you multiply two things together, 3 times 0 is 0, or 0 times 5 is 0, you see how when you're multiplying two items or even more of them, you know, if any of the factors is 0, it makes that statement true. So can you see how this, if this piece is 0, it doesn't matter what that piece is, then the statement is true. So if I call this A and I call this B, you know, it doesn't matter. I'm just telling you, you know, when you're multiplying two items, if either one of them is 0, it makes that statement true. So that's the solution. So then you set each one equal to 0. And then you solve each individual piece. Now they're linear. You see, linear means you can isolate that x. In the classroom, when I have time, we take this trinomial here, this trinomial, and we try getting an x by itself by not factoring, and it's impossible. Because you can move that 6x over, but then when you divide, you have x's on both sides, or you take the square root. It just doesn't work. So you have to use this process. So you use a zero factor law, and then you solve each one. That's the steps. And then you should check, and I'm telling you, I don't have time for that right now, okay? But checking means you put it back into the original and see if it makes a true statement. Now, some of the homework you're going to be given is going to be, might look like I want to do one in a different color real quick. And then that might be all I do here, and then I'll start trying to do something with word problems. How are we doing? It's really hard with Zoom because I'm not getting feedback very much, and I know it's a pain for you to have to unmute and talk and all that stuff, but I just want to make sure that we're okay. And some of you are taking notes, so I need to slow down a little.
So far, so good.
Yep, this
Okay.
is all making pretty much sense to me.
It makes sense? Very good.
Yes.
Okay, good. So let's say you're given something a little bit different. Okay, so I'm going to do this up here. Oh, I can't write this stuff today. Let's say you're given something that looks like this. You know, let's say. Then I don't want you to do step one, because you need to recognize you have something times something equals 0 already, you see? So skip step one. You don't want to create standard form, because if you do, you're going to have to turn around and factor, you see? Skip steps 1 and 2 in this case, because already A times B equals 0. So you go straight to step 3. So this one's cake. This is a gift. So you have x plus 7 is 0, so x is negative 7. X minus 2 is 0, x is 2. Just saying. So don't make it worse. Some people spend 10 minutes doing all this and then figuring out how to factor it. Sometimes they're worse looking than this. You know, what if this is a 3x? But anyway, here, in this case, you don't have a choice, because you have something times something equals 3x, and there is no law that you can use. Zero factor law means this thing has to be a 0. How would I?
That's good.
Good? Okay. So, and sometimes fractions are okay. You know, you might be given something like this. Some people freak out. Okay, so you already have it factored. That's great. And then you say, well, this one, you have to isolate that x, but that's then basic math, right? You subtract the 5 over. And x is negative 5/2. And then they want to give me decimals and stuff, or mixed numbers. We don't want that. Improper fractions are the best. And then this one's just x is 3. So some people skip a step and they don't do from here to here. You see how I could just say, what would x have to be to make this thing 0? So they would know immediately that's a 3. Or you can go through the process of x minus 3 equals 0. So x is 3 because you add 3. So different people work this stuff depending on their basics. But it doesn't matter. Can I clear it?
Yep.
Yes.
Okay. So, oops, I'd help if I had a mouse. Okay, so let me look through this test and see if at the end I have word problems of some kind. Oh, this is domain. Nope. Okay, so at the end of chapter 6, we have some word. I don't want to scare you with this stuff. This looks pretty bad. Ignore me for now. Okay, so here's a word problem. But this word problem has to do with chapter 7. You're not ready for that. So Markeisha, I kind of need one from chapter 6.
Okay, let me pull it up on my notes real quick.
Because if it doesn't take you very long, I will just do it real quick here.
Let me see, did I get this one?
And I might write it down quickly or whatever, but.
Yes, if I can get out of here.
And it might have integer problems too, does it?
I believe so.
Okay, so I'm pretty sure I have video on just a bunch of word problems that I would probably ask you to watch first. But I'm happy to work one, but then to clarify it and really bring it home, you need practice and different views, not just always the same exact type of problem.
Right. I'm trying to pull up these assignments, see if I can pull one up real quick.
I'm gonna
If I even stop doing it.
Okay, let me know if you find one. I'm gonna look real quick. The problem is I just started using this computer last year. So I have a lot of good stuff on my little bitty one, but that's hard for me to see.
Okay,
You got
that's not a good example. That one's not a good example because that one was kind of self-explanatory.
Oh,
I've been using the question help, where it was like, help me solve this problem.
yeah.
And trying to go through there. Okay, so here's one. And it just says represent the given condition using the single variable x. So the base and height of a triangle whose height is 9 more than 9 times its base.
Okay, just a second, hang on. This silly thing gave me the wrong pen or whatever. Okay, we want the base and height of a triangle, right? Okay,
Yes.
So tell me again, the base
and the height of a triangle.
Yes.
Whose height is 9 more than 9 times its base.
Okay, hang on a minute. 9 more than 9 times its base.
Yes.
And they just want you to represent them in terms of x. They don't want you to solve.
Let me double check. Yes, it just says represent.
Okay. So I want you to look at this. This is a little different. Let me do something first. Something that's a little more basic, okay? So I'm going to say same thing, like represent it. Let's use a rectangle. And we're going to say, I want you to represent the base and height of a rectangle, or the length and width, right? Because it's the same thing. And the height or the width is 7 less than 3 times the length. I'm just making this up right now, but I just want you to kind of learn how to read these and learn how to translate. This is something that should be done heavily at the end of pre-algebra, because if you can't translate, you're going to suffer through these, like these are going to be hard. So first, I always do a little sketch, a little sketch helps, and you're going to have a width and you're going to have a length. Or you could call this a base and a height, couldn't you, on a rectangle? And then I want you to say, hey, what am I looking for? What do you want? You want to know what is the width? You're looking for the width. Whoops. You're looking for width and you're looking for the length. So we're going to let x be something. And I mean, this is the key, let x be. This is really important. Let x be. So you first have to let x be whatever the other one is based on. So you're going to ask here, the width is 7 less than 3 times the length. It's usually and often in these type of problems, it's the last word per sentence. Not always, but this is a little trick until you get really comfortable with this. the last word first sentence. Now this won't work with integers, but it does work with these shapes. So last word first sentence. And you can also ask, what is the other one based on? You know, what is it based on? So you say, well, if the width is 7 less than 3 times the length, it's based on the length, isn't it? The width is based
Yes.
on the length. So we're going to let x be. So you say, let x be the length. And then you say, and some people use the equal sign. It doesn't matter, you know? Let x be the length. And then you say, what else do you need? And you keep this left side blank. People want to immediately put something here. And what you really need to do is just say, let x be the length. What else do you need? The width, in this case of my rectangle. And then you need to find this right here. This is what you're looking for. This is whatever you translate here.
Okay.
So you say, let x be the length. Well, what else do you need? The width. Then you read, the width is 7 less than 3 times the length. You see, 7 less than 3 times the length. You said length is x. Do you see it?
Mm-hmm.
And now this translates nicely. I mean, you can double check it against the wording. But the width is 7 less than 3 times the length. So then if they gave you, hey, the area of that rectangle is so-and-so, then you would multiply the width times the length and figure out what each piece is. So that's the goal later, you know?
Okay.
So let's translate this into the triangle, but I wanted the rectangle first because the rectangle is easier. Now on a triangle, you would say, hey, I can do a sketch. And it's okay, so I don't, sometimes I sketch it like this, but then the height is really bigger. You know, in this case, I'm kind of looking at it. It doesn't matter. Sketch does not matter if it looks great and if it makes sense. So we're going to say let x be. So the height is 9 more than 9 times its base. Last word first sentence. Or last word in a sentence. It depends on what they're talking about. So what should x be?
The base.
Perfect. And once you do that, and people think that's so pointless, I don't need to do that. And I'm like, that's exactly what you need to do, because then you can focus and figure it all out. And if you set this up right, everything works. Students want immediate answers. And it's like, if you spend 5 minutes figuring this out, you will have a correct answer, and it was time well spent anyway. So what else do you need? Height. Yes?
Yes.
So you say, let x be the base, and then you translate right here is what you do, what I did down here in pink. Height is 9 more than 9 times the base. 9 more, and I always hang it at the end, because when you have less, you can't say 7 minus 3x. You know, it doesn't work. But when you hang it at the end, it always works. So 9 more than what goes here?
9x.
You see it?
Yes.
So then this is x, and this is 9x plus 9. And this is just, they want you to learn to set up problems, because you're going to eventually solve. Right now, they just want you to express this. What if, they didn't give you more information, but what if they said, and this isn't going to work number-wise, but what if they said the area of the triangle is 68 square meters, you know, for example? Then you would say, oh, this times this would make that rectangle. You might need the formula, you know, and you would say, oh, this times this divided by 2 is 68, and then you have an equation, etc. That's just later.
Okay.
Does this help at all? It's just the setting up of it is really critical.
Yes, well, see, I wasn't even setting it up like that, and so that makes a lot more sense.
Okay, good. Because it's, I mean, you can break it down. People get so overwhelmed, they're terrified of word problems, but if you kind of approach them calm and then you write a picture, do a picture if you can, you're going to have integer problems, which can be, I wonder if you have one of those handy or
An
maybe not.
integer, I do. It was question number 2. Because after question number 2, I was like, I'm done for the day.
Yeah.
Okay. It said represent the given condition using a single variable x, 2 consecutive even integers. Let x be the first or smaller.
And they're even telling you what to do.
Yes.
Oh, so this is just actually, this is the end already? Let x be the
I mean,
smaller one?
Yes, and then it just says
Okay.
where the answer is let x be the first or smaller even integers.
Okay, so really, this is really the basic of integers. I wish I had one from, it's even at the end of pre-algebra I was teaching those. They get pretty involved for, I wish I had one handy. But sometimes it'll say the product of the first and third of 3 consecutive even integers is so and so, find the integers. It can be pretty intimidating, but it really isn't. So what I want you to remember is this: when you see integers, you just sketch a number line.
Okay.
And you're just going to sketch a number line and keep it as basic as you can. So in this case, what do you have? So for example, let's use don't use the 0 and the negatives right now. Give me an example of even integers and don't put them close to 0. Even integer just means a complete
12,
number. 12?
12 and 10.
Okay. And then which one would be next? 14,
14.
right? And these are even because you're reading the word even. Now, you have to represent them in terms of x. So I always, if you have integers, you always let x be the first. Okay?
Okay.
X be the first integer always. So we're just gonna label one and call it x. So in this case, let x be the first, that's automatic. And then what do you say? You also need the second, right? So
yes.
I'm not doing this the way I want. So x is the first, and then you say, what else do I need? I need a second. And sometimes you need a third. In this case, you don't, but I want to show you anyway. So then you say, okay, let x be the first. So you said, let x be this guy. You know, I'm not saying x is 10. So that's what I need people to understand. I'm not saying x is 10, but if x is 10, then what is this guy in terms of x? That's the critical question. So you guys can actually come up with this when you look at these numbers. If x is 10, what is this in terms of x? Meaning, how is it related to x?
I don't even know.
Oh, but you will, honestly. So if x is 10, can you see how 12 is 2 bigger than x?
Yes.
So if x is 10, then 12 is the next guy, and he is 2 bigger than the x.
Okay.
So because they're 2 apart. So this if x, let x be the first, and then the second is an x plus 2 because it's automatically 2 bigger because they're consecutive even.
Okay.
And then what would the third one be? If your problem asked you to fiddle with that, then you would say, what is this in terms of x? If x is 10, what is this in terms of x?
X plus 4?
Perfect. Because do you see how it's 4 away from the 10? Like they're related. And this is what you need. This isn't your final answer later. I mean, in this case it is, but later when it says the product of the first and third is 3 less than the second, then you have to translate. You know, and you have to find what X is. So you create
Okay,
an
that makes
equation
sense.
later on. You have to create an equation with these things. Now let's look at, I'm going to use different color. And let's look at what if it had said exactly the same thing, but 2 consecutive odd integers. Then you say, I'm going to let X be the first. And then I say, what else do I need? I need a second and a third. And I'm doing this kind of fast, but so then you draw your little number line. Now give me a number that is odd, integer.
9, 11.
So you have a 9, you have an 11, and you have a 13, consecutive odd. Then you say, let X be the first, so I'm gonna let X be this guy. Then what is the second in terms of X?
X plus 2.
You see it? Because 11 is 2 bigger than 9. So then it's X
Okay.
plus 2. And what is the third in terms of X?
X plus 4.
You see? And again,
Yes.
I'm not saying, some people say, well, you're saying X is 9. I'm like, I have no clue what X is. I'm just saying if X is 9. So this, then, these things is what you're going to use. But I have one more scenario, and it's different. So some people see the word odd. Do you see how these things are identical between even and odd consecutive integers? Because you agree 5, 7, 9 are 2 apart, 8, 10, 12 are 2 apart. So it doesn't matter if they're even or odd. If they're consecutive and they're either even or odd, they're 2 apart. So because some people want to put X plus 1 and X plus 3, I'm like, these numbers here aren't odd because 5 and 7 are 2 apart, you know, even though they're odd numbers. But
Yes.
let's look at the third thing that could happen. So I'll make it brown and we'll do it over here. Can you see this okay? This brown little rectangle here, whatever.
Yes.
What if it's just said 2, or I'm going to call it 3. You know, I should have said 3 because I'm trying to show you, because you're going to deal with 3 at some point. So 3 consecutive integers. What if I do that? You're going to say what? Let X be automatic, the first. Yes? And then you say, what else do I need? Second and third. And then you do your little sketch. And then you all come up with this. I'm going to make X, I'm going to start at 15. What's next?
16.
What's next?
17.
And I'm going to let X be the first one. Now you tell me what these other ones are in terms of X.
So X plus 1 and then X plus 2.
Yes, and do you see how fast that came just 5 minutes after we started discussing this? When you're
Yes.
like, I have no clue, and now it's solid because you understand this. And this is more important than the rest of the problem.
That
So
makes a
then
lot
you-
more sense.
Right? And then you have, and then we actually I would love to have an actual problem before we call this good for the day. I know, and there's people say, oh, you can't do more than 15-minute sessions. I'm like, I'd have to do several in one day.
Right.
And I know other people don't want to watch this stuff, but hopefully the people that do get something out of it. Then I go to YouTube, it's like 2 people watch this or 2 views. I'm like, I know it's math and nobody wants to see it, but then I get the same people that say, I can't do anything, I need help. And I'm like, why are you not watching these videos? Markeisha, I'm going to ask you for help one more time. Can you find one where they actually ask you, they actually try to solve something? They want you to find the number.
Like for an integer?
Yeah.
Yes, I just found one. That's what I was looking up. It says the sum of two integers is
Oh,
8.
no.
Not like that?
No, because what this is going to do, it's the same as their squares or something.
Yes.
And I have that in the video.
Okay.
That'll confuse things right now.
Okay, well, I don't want to do that.
Because we're just getting the other one, and that'll confuse it. Is there something else?
I'm not seeing any other ones. I
Okay.
just went through them all.
Bummer. Because sometimes it'll say, I'm just going to translate, and we're not going to get a good number out of it. But what if it says the product, and you don't need to write this down, of the first and third of 3 consecutive odd integers is 2 less than 3 times the second. And this is terrible, but I just want you to learn how to grab and translate and not be intimidated by this. So the first thing you do is you say the product of first, oh my gosh, that's a lot of words. I'm not even going to deal with this. It's an integer problem, let x be. So that's what you do. And then you say first, second, third, excuse me. And then you say, okay, what am I dealing with? I'm dealing with consecutive odd, yes? And you don't need to write this down. I'm just saying the video will be available. And then if you want to dig into this, but 3 consecutive odd. So, let's use that again. Let's use a 7, a 9, and 11. You all agree that these are 3 odd integers. So if x is the first one, then the second one is 2 bigger and the third one is 4 bigger. You see? And then translate, that's what people can't do. They can't set it up and they can't translate. Translate is you're going to turn this word mess into an equation that you can then solve. And once we get to the equation, people don't have a problem usually. It's that translating. So first of all, you need to know what the product means. What does product mean? Multiply.
Multiplication.
Yes? So you have multiplication of what? The product of, you see, if you label these like you should, this is not going to be a problem. The product of the first and third. The first is x, and the third is x plus 4. You see it? So this, and then you check your work and say, oh, is this the product of the first and third? Yes. 3 consecutive integers, blah, blah. Is means equals. So right there is your equals. 2 less, we're going to hang that at the end because we can't say 2 minus. 3 times the second. 3 times, and the second integer is x plus 2. You see? And then you solve. And this isn't going to work because I made it up. But you would multiply this, and then you would distribute this. That's just basic then. And then you would combine this, and then you would create standard form, and then you would have to solve. Do you see what I'm saying? So this is all, the setting up is critical here, and then the translating is the other critical piece. Now, the one you have, I'm going to work it real quick for you. I mean, I'm going to get you started on it. I may not finish it because it's your homework. But yours, go ahead and give me the wording because I know that you guys all have to deal with this.
Okay. You said give you the wording?
Yeah, go ahead and tell me the one that I said hold off on it because it's slightly different. The sum.
Oh, I have to go back and find
Oh,
it.
sorry.
I'm pretty sure. No, you're okay. Click. There we go. Yes. Okay, so the sum of 2 integers is 8, and the sum of their squares is 34.
Yeah, this is not nice. And if this was a different book, what did you say, 84? No, some of the squares.
34.
34?
Yes.
What's not nice about this is, so I drill on how to deal with integers, and then this is different because guess what? They're not telling me they're consecutive. You see
Right.
it? It's just some random numbers. Now, sometimes these numbers are small enough. A lot of you are pretty bright and you figure out the answer without doing any of the math, and that's not good because when the numbers get weird, you have to be able to handle it. So we're gonna say, okay, do you agree if I say, do I want to make it x plus y? Oh, I struggle with this because if I use x's and y's and then later I say I don't want to use x's and y's, but you see how I can't use x and x plus 2 because they're not related. The integers are not related. So
Yes.
let x be the first. We're still going to do that integer. Or one integer, you know? We can say 1 because I can't even guarantee right now that it's going to be in that order. And then we say, well, y is the other. So I'm going to go ahead and use an x and a y because I can't say x plus 2. And I
Okay.
have to come up with this too, myself, you know. But then you say, well, the sum of two integers is 8. You see how you could translate that into an equation.
Yes.
So wouldn't you then say x plus y equals 8 because this tells you so?
Yes.
And then you have to go from there. Could you, if I ask you to, put the other integer in terms of x? And that's the thing. You see this? Since they're giving us this piece of information, could I then show y in terms of x? And this is very similar to some substitution you guys have already done. But
So like, would you like subtract x? Is that what you're saying?
yes, so couldn't you, right? Because couldn't you subtract the x and put this y in terms of x?
Okay.
You see
Yeah.
it? So you have to use a piece of this sentence to say, oh, one integer is x, the other integer is 8 minus x, because of they're giving you this information. You see?
Okay.
And now you have to do another separate equation. You can't put this all into one like I did on that last one. And you say, oh, the sum of their squares is 34. So the sum means plus their squares. So the x squared and the y squared. You see, and you could write that as x squared plus y squared is 34. Some of you will do that, but I usually skip this. I go straight to this. The first integer is x, or one of them. And the y is an 8 minus x. You see, you need, here you have two unknowns and you can't solve. Here you have one unknown. Oops, here, you didn't see that. Y is 8 minus x, right?
Yes.
This is kind of mean. But you see this? Now all you have is x's and you can solve. Because if you have just one variable in an equation, you can solve it. How's that?
Okay.
Yeah?
Yes.
So kind of hideous, but it'll be okay. Now, here, one main mistake people make, here, they call this 64 minus x squared, and that is not true. And think about it. If you had that, then x squared minus x squared or plus x squared. You see what I'm saying?
Yes.
What is a minus b quantity squared? And I'll remind you of this. It's a minus b times a
plus.
minus b, right?
Yes.
So make sure you FOIL this piece. Then solve. I'm not going to finish it.
Okay.
Yes?
Yes.
Okay. and then I'll let you have it from there, and we'll deal with it again if it comes up. So are we
Okay.
good? Are we cooked? An hour and 20 minutes?
Yep, I'm good.
Okay, we've had enough. So I'll go ahead and upload this. It's not our greatest work ever, but it is what it is. And class is supposed to be spontaneous, and it's not supposed to be so canned as a regular video that I make. So thank you for coming, and thanks for participating. And thanks for
Thank
bringing
you.
problems. Ask questions, yes?
Yes.
Okay, we'll see you later.
All
Bye.
right. Have a good day.
You too, thank you.
Bye.
Bye.